I am Ekta. Welcome to the fascinating world of Euclid's geometry. Have you ever wondered how shapes and figures are defined and studied? In this lesson, we will learn about Euclid's postulates and axioms, which provide the fundamental rules for reasoning and constructing geometric shapes. We will explore how these principles help us define and understand the properties of points, lines, and angles. Learning outcomes. By the end of this lesson, you will be able to understand the fundamental concept of Euclid's geometry, including points, lines, and planes. Identify and apply the postulates and axioms of Euclidean geometry in problem solving. Differentiate between plane geometry and solid geometry and apply appropriate theorems. Recognize the significance of Euclidean geometry in real-world applications such as architecture and engineering. Keywords: Euclid geometry, postulates, axioms, points, lines, angles, geometric figures, construction. Children, what is Euclid's geometry? Euclid's geometry was introduced by the father of geometry, that is Euclid, and is also called Euclidean geometry. Geometry originated from the need for measuring land and was studied in various forms in every ancient civilization such as Egypt, Babylonia, India, etc. Euclid specifically spoke about the shape, size, and position of solid shape and various terms associated with them such as the surface, straight or curved lines, points, etc. Some of his fundamental about solid shapes are: a point has no parts, a line is a breadth less length, the ends of a line are points, a straight line is a line that lies evenly with the points on itself, a surface has a length and breadth only, the edge of a surface are lines. A plane surface is a surface that lies evenly with straight line on it. Let us see the definition of Euclid geometry. Euclid geometry or Euclidean geometry is the study of geometry based on undefined terms such as points, lines, and planes of flat spaces. In other words, it is the study of geometrical shapes, both plane shapes and solid shape, and the relationship between these shapes in terms of lines, points, and surfaces. Euclid's geometry deals with two main aspects: plane geometry and solid geometry. The table below mentions the theorems that were proved by Euclid. Now, let us see what is Euclid's axioms. Euclid's axioms or common notions are the assumptions of the obvious universal truths that have not been proven. But in his book Elements, Euclid wrote a few axioms or common notions related to geometric shapes. Let us take a look. Axiom 1. Things that are equal to the same thing are equal to one another. Suppose the area of a rectangle is equal to the area of a triangle, and the area of that triangle is equal to the area of a square. After applying the first axiom, we can say that the area of the triangle and the square are equal. For example, if P is equal to Q and Q is equal to R, therefore P is equal to R. Axiom 2. If equals are added to equals, the wholes are equal. Let us look at the line segment AB, where AP is equal to QB. When PQ is added to both sides, then according to axiom 2, AP plus PQ is equal to QB plus PQ. Therefore, AQ is equal to PB. Axiom 3. If equals are subtracted from equals, the remainders are equal. Consider rectangles ABCD and PQRS where the areas are equal. If the triangle XYZ is removed from both the rectangles, then according to axiom 3, the areas of the remaining portions of the two triangles are equal. Axiom 4. Things that coincide with one another are equal to one another. Consider line segment AB with C in the center. AC plus CB coincides with the line segment AB. Thus, by axiom 4, we can say that AC plus CB is equal to AB. Axiom 5. The whole is greater than the part. Using the same figure as above, AC is a part of AB. Thus, according to axiom 5, we can say that AB greater than AC. Axiom 6 and axiom 7. Things that are double of the same things are equal to one another. Things that are halves of the same things are equal to one another. Axiom 6 and 7 are interrelated. Consider two identical circles with radii r1 and r2 with diameters as d1 and d2 respectively. Since the circles are identical using both axioms 6 and 7, we can say that R1 is equal to R2 and D1 is equal to D2. Now let us study Euclid's postulate For discussing Euclid's postulate, there are few terms that we need to get familiarized with. Euclid's talk about a three-step process from solids to point, which is solid surface, lines, points. At each step, one dimension is lost from the shape. Therefore, a solid is a 3D shape, a surface is a 2D shape, a line is a one-dimension shape, and points are dimensions. These terms will help in understanding the postulates better. There is a 5 of Euclid's postulate. Let us take a look. Postulate 1. A straight line segment can be drawn for any two given points. This postulate shows us that at least one straight line passes through two distinct points, but it does not say that there cannot be more than one such line. Look at the line below. Only one line passes through P and Q, which is PQ, that passes through both Q and P respectively. Postulate 2. A line segment can be extended in either direction to form a line. A line segment can be extended in either direction to form a line is the second postulate. Postulate 3. To describe a circle with any center and radius. A circle is considered as a plane figure that consists of a set of points that are equidistant from a reference point and can be drawn with its center and radius. According to the third postulate, the shape of a circle does not change when the radius is different. What changes is the size of the circle. Postulate 4. All right angles are equal to one another. A right angle measure at exactly 90 degrees irrespective of the length of their arms. Hence, according to postulate 4, all right angles are equal to each other. This holds good only for right angle triangles and not acute angle triangles or obtuse angle triangles. Postulate 5. If two lines are intersected by a third in such a way that the sum of the inner angles on one side is less than two right angles, then the two lines will intersect each other on that side if reduced indefinitely. When there are two lines cut by a third line, if the sum of the interior angle is less than 180 degree, then the two lines will meet when extended on that side. In the image given below, angle 1 plus angle 2 less than 180 degree. Therefore, lines M and N will meet when extended on the side of 1 and 2. Non-Euclidean geometry. There is a branch of geometry known as non-Euclidean geometry. Basically, it is everything that does not fall under Euclidean geometry. However, it is commonly used to describe spherical geometry and hyperbolic geometry. Since spherical geometry comes under non-Euclidean geometry, to convert it to Euclidean or Euclid's geometry or basic geometry, we need to change actual distance, location of points, area of the regions and actual angles. Points to remember. Euclid geometry is based on undefined terms, axioms and postulates. Euclid's axioms represent self-evident truths used as assumption in geometric reasoning. Postulates define the relationship between points, lines and angles in Euclidean geometry. Non-Euclidean geometry encompasses spherical and hyperbolic geometry, which differs from Euclidean geometry in terms of distances, angles and areas. Thanks for watching.